some applications here. When you do these application problems, I can't stress enough that you need to read and underline or highlight. Sometimes sketching a graph will help, most of the time, and a lot of times you can do that on your calculator. Make sure you note the domain restrictions and the units that the problem is talking about. And if it asks for a rate of change, differentiate, or if it gives you a rate of change, you know that you have a derivative already. And before coming to an answer, so before writing down your final answer, reread the question and make sure you're answering what they're looking for. Okay, so while out on his trawler, John North, a fisherman, notes that the height of the tide in the harbor can be found by using this equation, and that's the height of the tide. Yeah? And so I know H is in meters, there's my units, and T is the number of hours after midnight. So that's kind of important because when they say 2, they're meaning 2 a.m. All right, great. So it says, what is the height of the high tide and when does it occur? Okay, high tide. So I'm looking for a maximum. And lots of times when we're doing problems and we want a max, we take the derivative and set it equal to 0, which we could easily do, and it would work. But there's an easier way with trig functions. So max and min with trig functions is easy, okay? Because I know that with both trig functions, they stay between 1 and -1, okay? The sine looks like that, and the cos looks like that. They stay between 1 and -1. Now, obviously, this thing doesn't stay between 1 and -1, the height, but this little part does. The other day, we were isolating the trig function to solve, and so that's what I'm going to do right now. I'm going to say to you, this bit stays between 1 and -1. So I know the maximum value is when this is 1. There's nothing bigger that this can be than 1. So the max value is when cos of pi on 6t equals 1. So that's 5 plus 2 or 7. And I'm in meters, so that's the maximum height. And then it says, and when does this occur? Okay, so for the and when does this occur part, I have to solve this equation. So I'm going to solve for time here for the and when does this occur. Okay, so in the first 24 hours. So my domain is for 24 hours. So I'm going to say, when is cos 1? Let's see, it's 1 here. And so it's when pi on 6t equals 1. Let's see what I get when I do that. I get t equals 6 on pi. Oops, sorry. Not 1. Never mind. It's when it equals 0. That's 0 there. I haven't gone anywhere. So I get t equals 0. So at t equals 0, I think I have a high point. Sorry, you can't see that. All right, now I need to figure out the other values for when that happens. So maybe this far around. Is that in the domain? I'm not positive yet because my domain is 24 hours. So I'm going to see if it is there. 2 pi all the way around. And when I divide by this, when you divide by pi on 6, you're really multiplying by 6 on pi. Right, when you divide by pi on 6, you're really doing 2 pi on 1 times 6 on pi, right? That keep, change, flip idea. And that equals 12. So I'm still in my domain 12 hours after. Let's try to go all the way around again to 4 pi. So 4 pi times 6 on pi gives me 24. Well, I'm not going to try anymore because that's the last point in my domain. So at 0 and 12 and 24, that's when I reach the maximum height. Okay, great. That's good. Now it says, what is the difference in height between high and low tides? Well, this is the maximum, the high tide. So the low tide is going to be the lowest value, and that's -1. So 5 minus 2, or 3 meters. That's the lowest tide. And then it says, oh, what's the difference? So difference, I know I'm all over the place here. The difference in high and low sorry about that bad spelling, high and low, 7 minus 3 equals 4 meters is the difference. Okay, so that is B. Now C says sketch the graph. You can easily do this on your calculator, but I can see it already here. I know the high tide's 7. I know the low tide is 3. The equilibrium is there when height equals 5. I know I go up to 24 hours. So I'm going to split it into my little bits here. How do I know to do that? I do it every time I do a trig function. I write this, I cut it in half, and I cut it in half. And I know at 0 I have a high tide, and at 12 I have a high tide, and at 24 I have a high tide. And that would put my low tides here because of the symmetry. And so I can just graph that. So I've sketched a graph, plenty of stuff there for a graph. And then it says, John North knows that his trawler needs a depth of 6 meters to enter the harbor. Between what hours is he able to bring his boat back into harbor? Okay, I'm going to kind of use this graph and say, you know, here's 6. I'll even do it in yellow so we can look at it. So I need to get in between here and here. These are the values I'm looking for, all these little t's, and then here and here. So this is like a perfect question to do on our calculator. So let's grab that. And I'm going to type in the function 5 plus 2 cos pi, oops, I did something wrong there. Let's see what I did wrong. Pi on 6x. And for my window, I think I'll go up to 8. I'm sorry, x min will be -1. That's fine. I'll go up to 25. That's fine. And that scale, remember we were saying we should put in that first number. 6 is good. And the y min, just so I can see the x-axis, I'll put that in. And I'll go up to 8. That looks good. I must have graphed this already before I had it with you. So I can see my function there, so that's really good. And now I'm going to type in y equals 6, because that's what I want to see. And I can just go in and go second calc, and I want to see where they intersect so I can get those values. I'm going to get all the way over here. Once I get 1 or 2, it might be able to see. So that's 1, 2, 3, and it intersects at x equals 2. So from 2 a.m., now I'm going the same distance on either side of here because this has symmetry. So from 2 to 6 is 4, 6 to 4, so 2 a.m. to 10 a.m. Okay, if you can't see that, then hit second calc intersect and scooch over to where that next intersection is. And it says 10, and then you can find the other 2. Okay, I think that's up to you. That's fine. I didn't put any problems yet. You can do whichever problems you want. We'll probably do all of them in the end.